All right.
Hey, so thanks for joining us today. This is the last time we're giving this talk. So our focus, my name is Matt. My background is actually in additive for 10 years now. And our focus is trying to help customers with their production in terms of retaining tribal knowledge and maximizing efficiency through data-driven decisions. And we decided to give this talk here today at Dendrite in order to kind of discuss what are some great takeaways that you can have in terms of your production that you can implement right away without really sacrificing a lot of time. In fact, gaining time. And so we wanted to talk about profitability in AM. And obviously there's a lot of factors that go into this, but there are some levers that you can utilize that are completely free. And why should we be the ones that are talking about it, right? So we've been working in the industry now for 6 years. Our major focus is to help customers get into qualification or get through qualification or get into production. And our big focus is how do you do this on the operational side? We've noticed a lot of times that customers ask us for help with their parameters, with their quality, and then at the end of the day, it comes down to the execution. In other words, whatever tools you provide to them, the question is how do you use those tools? And when we realized that, we started focusing on what is now called Uptimo, which is a software that we built, actually more than just a software solution, that actually quantifies everything you do in production from an operational excellence perspective. The operational excellence perspective is something that is not done in additive. And then how do we use that information and bring that information over into helping you make data-driven decisions? So giving actionable results in terms of this is what I need to focus on right now, and I can ignore everything else because there's in production a lot of noise. So for this talk, I actually prepared an example from a customer that we have. And it simply is a production facility that has 7 M2 systems. So these are the smaller machines that are around $500,000. And then 2 M4 systems. And with these 9 systems, we've noticed that our customer has been running at around an efficiency of 40%. Now I know that sounds a little bit incredulous right now, but this is one of the more competent customers that are actually getting to be profitable. Normally, it actually gets even worse. We'll get into why about that in a second. Their setup is a typical one where they have a production manager, they have 2 project managers, in other words, 2 engineers that are preparing the jobs, actually managing the entire project from the beginning to end for our customer, 2 machine operators and a salesperson. And the general breakdown for their production is that for our costing, the production manager is around $150,000. The project managers are $100,000, the machine operators are $50,000, and the salesperson is $150,000. And that's, quite frankly, at this point, a little bit unrealistic because all those numbers have gone up. So if you can extrapolate that as I give this talk, this problem has actually just gotten worse. So when we look at this kind of a setup, we've noticed that the customer was actually spending around 20 hours a week as a production manager, 5 hours every project manager, 5 hours every machine operator, and about 20 hours a salesperson. So 60 hours a week in terms of where are my builds, how are my machines performing, where is the powder, how much powder do I have to sieve. We need to get back to the customer because there was a breakdown and we have to reprioritize everything. There was something going on with our suppliers in terms of post-processing and all of this coordination, which is just extremely chaotic. And when you're doing this in a reactive mode, that just makes it even worse. And so what does that mean financially, right? If you now, instead of doing this, if you spend time on actually collaborating with your engineers and actually making really good parts, which is technically your focus, obviously you need much better for it. But the thing is though, is that in order to do all these steps, you have to actually have a pretty good engineering understanding of the process. And so how do we outsource that, right? How do we retain that tribal knowledge in order to make sure that anybody can execute this so that they don't need a lot of experience in the AM production environment? Now, if you then are able to focus on just collaborating and making good parts, then your efficiency is going to go up automatically by around 20%. And the resulting consequences of that is that you're going to save around $12,000 in personnel costs a month, around $15,000 on these machines, and then around 9,000 in terms of rejections of parts, and also the excess capacity of powder that you have just to make sure that everything is running correctly, because just in case you screwed something up, that you have enough powder. So from our perspective, what we have is a cockpit in our software that actually gives you a breakdown of everything in your production according to machines, builds, people, and powder. And the reasoning behind this is that the machine is the most expensive asset in your production, and it's one that we price according to, it has a certain utilization. And so when we first take a look at the cockpit, everything is color-coded in red, yellow, and green. And the green are in this case, the systems that you don't have to worry about. The yellow ones are the ones that are something is happening that is critical and just keep an eye on it. And then the red stuff, hey there. And the red stuff is the stuff that you actually have to focus on right now. And the software actually tells you exactly why you need to do that and exactly what you should take as a corrective action in order to make sure that everything's running successfully. Sorry, I blurred this out because this is actually from customer information, so I just wanted to make it anonymous and you just have a focus on here. The build, on the other hand, is something that we have what's called a queue concept, and we'll get into why in a second, but basically the software is overlaying the schedule of your production, in other words, everybody that's in production, and then telling you, do you have enough things in terms of redundancy to make sure that the machine will be running successfully even if something goes wrong. And so if you don't have enough capacity, so for example, it's a Friday, right? You need to have a build that is going to carry you over until Monday because nobody's in the factory on Saturday and Sunday. On the other hand, if it's a Thursday, you just need a 24-hour build. And then the people aspect is looked at it from a completely different dimension where I don't care what the tasks are. What I need to know is when are my people necessary to actually execute on the task. So if you have, let's say, X number of people and X plus 1 number of tasks, that's an issue, right? That's an issue because you don't have enough people to actually handle everything to make sure that it's being done on time. And then finally, the powder is actually trying to anticipate when do you have enough powder for the projects that are coming up, as well as what else do you have to do, which is specifically sieving, which takes a lot of time. We anticipate that and tell you, hey, if you have this job at 4 o'clock and it's going to take 3 hours to sieve because you have this quantity of powder that is unsieved and it's in your inventory, then you need to start at 1 o'clock. And so that you're not in reactive mode. And this is again color-coded in that same fashion. The whole principle behind this is that imagine you have a plane that lands and then there's this ground crew that's actually taking care of everything to load the plane with new fuel and equipment and passengers. The last thing that you want is actually for the plane to be standing there longer than it needs to be, because if the plane is not in the air, it's not making money. And in fact, it's actually spending money for the time at the airport. So the two main takeaways from that context that I just presented to you at the end of this presentation is that you need to have redundancy in your production, right? That's number one, which is make sure that the machine is running all the time. And of course, this is not ignoring any post-processing steps. Those are equally important. However, those post-processing steps, keep in mind, are linear in nature. And this is the reason why we focus on the machine, because the machine is so intricately involved with the people that you have, as well as the other projects that you're running. And then build optimization is not a problem of how can we cram more parts into the machine. That's actually a very bad approach to looking at it. So what do we mean by efficiency, by the way? Maybe we should start with that. Efficiency is coming from operational excellence in terms of OEE, which is we're trying to understand how much the machine is running, how fast it's running, and how the output is of that machine. Because quite frankly, if the machine is running all the time and all the parts are thrown in the garbage, the efficiency is 0. On the other hand, if the machine is running half the time and then half the output is garbage, then that's 50% times 50%, that's 25% efficiency. So efficiency metrics, for people that don't come from operational excellence, are extremely brutal, and they tend to disagree with them. There's this moment of cognitive dissonance of, why is this so low? Well, that's the reality, right? Just do the math on that. So it's 3 efficiency quantifications, and typically in additive, all we're really quantifying is the uptime of systems, and then we're trying to extrapolate that into our machine hourly rate, which is a huge problem, because if you're thinking that your uptime is 80%, and then it turns out that your efficiency is actually 20% because everything you printed was garbage, well, you just lost a lot of money at the end of the year, where you realize at the end of the year that your resultant efficiency has resulted in hundreds of thousands of dollars, typically around $300,000 per machine in a factory. And so this is one of the reasons of why companies in metal additive are having a hard time with profitability. So we divide those three, uptime, speed, and output, into planning parameters and parts, and we call that internally the AMI, the Additive Manufacturing Index. So you just kind of ask yourself, what is the AMI for this job? What is the AMI for this machine? And then you can actually answer the question of what do we need to do in order to improve our output. So in a typical production environment that is not additive, we have a continuous manufacturing process where the parts that are coming out are automatically assessed and then feed back into this is what the efficiency is, because remember, we have to have that part metric at the end. In additive, that doesn't really make sense because of the fact that the parts are different every single time, the duration of the builds is different every single time, and so what we have is we have this conclusion that is very much delayed, because after you start that job, there's nothing you can do about it, right? If you stop it, you're losing efficiency. And so you actually have to plan things in advance. And so we actually have to take the data in a completely different way and agglomerate and analyze it from the perspective of what is actually happening in my efficiency. We won't get into that topic, but we will talk about how we can prevent some of these inefficiencies from happening to begin with. But what we noticed with customers that are actually in serial production for a number of years, actually in additive, is that their efficiency plateaus at around 40 to 45%. Typical additive facility has a break-even point of around 45% efficiency. And so what they're seeing is that they're just barely breaking even, but it's really hard to discern that signal from the noise of, well, we're making further investments, and so this is why, we're not profitable. But that's quite dishonest. If you were to stop investing, then you would notice that actually your profitability is just barely there. And we're not even talking about the 20 to 30% margins that normal manufacturing companies have. And the other thing is that when companies are getting ramped up in the beginning of their first 2 years of production, they're usually hovering around 20% efficiency. So what can we do about that, right? Well, one of the reasons, and this is one that we're going to talk about in this talk, is this push-pull concept in production. In a typical manufacturing environment, we use what's called Kanban, and we have a pull system. In other words, the last step in production is actually calling the second to last step to say, hey, I need another thing to work on. And so everything is actually happening from the tail end to the front. So if you have 10 steps in production, the 10th step is saying, hey, 9th step, I need something. The 9th step is saying, hey, 8th step, I need something because I have extra capacity. And in that manufacturing style, number one, you usually have a lot higher volumes, you have higher inventory, but also you assume that the output is perfect or nearly perfect. So Six Sigma is the idea that 99.9999% of your output is good. Now, in additive, we're nowhere close to that. The typical output rejections in metal additive are 20% if you're good, and they actually can be higher, but the question is, again, is people have a hard time quantifying that. So because we don't have that concept, or we cannot fulfill those criteria, and the delay in the process is so high, what we have to do is we have to have a push system leading all the way up to the machine printing process, because again, that is the thing that you want to have, like a plane up in the air running all the time. So what we do is we have actually all the resources that are necessary in production that need to be supplied into the machine, right? Just as I mentioned, because AM is the most expensive part. So the first thing that we focus on is the powder, right? Now there are two things you can do. You can either buy a lot of powder, or you can get clever with your powder strategy. So buying a lot of powder means that you typically have for a single alloy around $100,000 to $200,000 in inventory at any time for the small systems. And then for the larger systems, you literally have $200,000 in the machine. So you need to have around $1 million. And if you then start having other alloys and you're switching similar alloys or completely different alloys, we're talking about an inventory of $1 to $1.5 million in your production. That's not very good, right? There's a lot of money that you could be spent doing something else. And let alone, I can't tell you how many situations I've seen where someone bought a lot of powder with the promise of some certain production coming, and then that production never materialized, and now they have, $100,000 or $200,000 worth of powder that is sitting there for 6 to 12 months. And then again, it's kind of like the ugly stepchild where nobody wants to touch that powder. So the other thing that you can do is you can actually get very clever in terms of predicting what your powder consumption is. And we do that with our analytics, but just think about it from the perspective of how much powder do I need for a build? Build out a simple Excel spreadsheet that gives you a rough estimation in terms of the powder for the build that you have and then all the upcoming builds. Proportional to the build height, the filter consumption, add an extra 20% for that, and you're going to be good. And then you're going to notice that your margins of powder inventory are going to go down by 50%. And then of course, in that scenario, what you have to do is you have to make sure that every time that powder is completed, you have to sieve it right away in order to anticipate the next project that's coming. The other thing you can focus on is your people, right? In additive right now, like I mentioned, that's kind of a problem. People come and go very frequently because the demand is so high, and there's not a lot of people that actually stick around in the facility for the next 3, 4, 5 years. So what we have to have is we have to have an ability to outsource that information that they require so that you can actually bring people on board really quickly. Paying them more is also quite nice, as long as you can justify it. And I'm kind of a big fan of that one. And then the other thing is carefully plan out your production so that they actually get to do fun things rather than trying to figure out all the issues that you've created for them because your schedule is messed up. So in other words, plan out your production, not from the moment that you start production, but from the moment that the production ends, right? If you're focusing on Monday for all the jobs that will get started, why don't you think about when those jobs end and what are the consequences for the people that actually have to turn those machines around? Because if you have, let's say, 2 people and then 4 projects end at one time, nobody likes you. Then the last thing is this simple concept that I mentioned is implementing a build queue. Right? If you implement a build queue, then automatically you have the ability in order to see what's going wrong, and if something happens that is an issue, you can anticipate it and empower your machine operators in order to launch the next job without having to ask people 15 questions about, is the customer okay with this, or should I wait for this project to be restarted, which is extremely unrealistic and a huge waste of money. If you don't do this, right, you basically have 2 value propositions. The first one is, we make some unique applications. Now, I can't tell you how many times people think in terms of their innovation that what they've created is amazing, and then all of a sudden someone else is doing the same exact thing. Because manufacturing unique applications in additive, especially when someone knows that you've already figured it out, they're gonna dedicate a lot more resources to doing exactly the same thing because they know it's possible. That's part of the innovation process, right? The second thing is that the only thing that you have as a competitive advantage is your price, because of the fact that you're buying exactly the same machines as everybody else's, exactly the same parameters as everybody else's, and exactly the same powder. So there's no competitive advantage there except for we can do things cheaper, right? So let's just cut our margins. And now in this technology that is extremely expensive, the only thing you're talking about is price, which is not the reason why people choose additive. And so instead, why not focus on competitive advantage with operational excellence, right? Why not focus on reducing your cost per part by 30% by just doing your work better, and then actually making sure that people can collaborate and have fun at their work rather than just try to scramble and put out the next fire, which is literally happening every single day. And one of the other things that you could focus on that with operational excellence is also build optimization. The only thing is I don't really have good news on that side is that build optimization is not what you think it is, right? Build optimization for most customers is that we just add more parts. And adding more parts is not a solution as long as the production efficiency is not going up. So the first thing about production efficiency is that we have to consider the schedule of our production. If there are people not in the factory, it doesn't matter how many parts you put on a build. If you have a job that runs for 6 days and it's in serial production, and I did air quotes because, you know, sometimes we say that it is, but not exactly. Different meanings of serial production. Then you notice right away that at a certain point you're gonna have a job that ends on a Friday night and nothing is running on a weekend. So why did you spend all that time optimizing things? In fact, what you've done is you've increased the risk factor that a 6-day job is going to crash on day 5, and then you've lost 5 days of productivity. The second thing is on a single build level, you have to consider that each parameter set is very, very different. So depending on the alloys that you're working with, the exposure rate is affected differently when you add more parts to the build. And that's because the recoding time is a different proportion of the building time in terms of Inconel or a titanium. And I'll get into an example about that in a second. The second thing is this has to do a little bit with qualified parameter sets, is that customers typically say, like, I can't change this parameter set because it's qualified by the customer. But that's not exactly true. What we do when we qualify the parameter set is we do mechanical tests, and those mechanical tests are usually based around the inskins, which is 99% of the volume. However, 1% of the volume, which is the contours, upskins, and downskins, takes around 30% of the build time. And that's not really qualified because that can actually be post-processed later on, and nobody has a problem with don't touch this part out of the machine because it's been qualified, right? So that's a little bit of a dichotomy. We have to separate those things, and that goes into qualification of operation qualification, performance qualification, but we won't get into that today. So what we can do is number one, address the fact that complexity is not free. In additive, complexity being free is an absolute lie. And I know I'm not going to get a lot of fans about that, but it has to be said, right? If I can drill a hole for 50 cents, why am I printing it and spending an extra day doing it? So in order to kind of demonstrate this example, I gave a very generic chart here. You can actually apply numbers to this. It does actually correlate with the two trends that I have here. And that basically is, if you're printing in an Inconel process and you have a build that takes 20 hours, and then you double the number of parts, the build time is going to be around 38 hours. And the reason for that is because on Inconel, the recoding time is actually a very small fraction of the build time. The exposure of the process, because of the anomalies that we have in Inconel, because of the way that the energy is transferred into the material, is the thing that affects it and actually makes the exposure rate be very slow. On titanium, on the other hand, if you have a build that is 20 hours long and you double the number of parts, the build time is going to be 25 hours. Because of the fact that actually most of the time that is inefficient is being spent on the recoding. And so when you look at that metric, you are either experienced with Inconel type materials or titanium type materials. And then you start extrapolating that to all the other jobs that you're running. And then you start actually making very bad practices where you're running an Inconel job and you go, oh, if I add more parts to this, everything's gonna be fantastic. It's not. It's actually very, very not. What you're doing is you're actually increasing the risk that you're gonna have a longer job that's gonna fail. Because you have to consider also, with more parts, the residual stresses in the geometry are gonna be different. So when you take a look at that example, the question that you want to ask yourself is, well, actually, maybe I should be focusing on the cost per part, or in our reality, on the parameter metric, which is the efficiency of the build. So not only adding more parts to the build, but then also considering, can I maybe optimize the exposure settings, right? And I'm, again, not talking about the inskins, because the inskins is the thing that actually delivers the quality, which is then correlated to your fatigue and your creep results, and that's something we don't want to mess with. I'm talking about the geometry-specific parameters, which is your contours, upskins, and downskins, and maybe turn off some supports. So when we're dwelling on these two aspects, we have to kind of understand what is the contribution of each, and actually maybe have a rule of thumb for every different arrow. So that about wraps up my talk. My lesson, I think my takeaway for this is you should use Uptimo, of course, because we do actually quantify these things and tell you exactly what to do at any time. But if you're not using Uptimo, think about redundancy in your production. That's an extremely important aspect in terms of making sure that your machines are running all the time. And then the second thing is, when you're quantifying the efficiency of a build, focus on the number of parts as well as the exposure parameters that you're running, because these two levers are very powerful and you have to overlay that with your production scheduling. And for doing that, you do have softwares like Dindrag, which are actually very helpful. So, thank you.